Sums and products of functions. Okay, when we add or multiply two functions together, the resultant function will have a domain of where those two things intersect. So here, if I've got f of x as root x plus 2 and g of x as root 4 minus x, we've got f, let's change to my favourite red pen, I've got f plus g of x is root x minus 2 plus root 4 minus x. Now we know our domain of the first one is x is greater than or equal to 2, and our domain of the second one is x is less than or equal to 4. So we need to draw a number line 2 to infinity, 4 to negative infinity. Where do they cross over? They cross over from 2 to 4. So our domain is x as an element of 2 to 4, and it includes both of them. And you can test it. If you put a number outside of like 5, if we put 5 into this function, it's okay. If we put 5 into this function, it'll be negative, and we can't work that out. F plus g of 3, so that's just saying f plus g of 3. That means use this function we've got here, so root 3 minus 2 plus root 4 minus 3. 3 minus 2 is 1, so I get root 1 plus 4 minus 3 is 1, so I get 1. Root 1 is 1 plus 1, I get 2. Okay, f times g of x, so that's the product of the two. That will be root x minus 2 times root 4 minus x. We can put them under the same square root, so x minus 2, 4 minus x. If you wanted to, you could expand that, but I wouldn't bother. And we also know that our domain will be exactly the same as what it is up here, because it's where the two functions intersect, which in this case, x is an element of 2 to 4. We know that it can't be anything outside of that, because we would end up with a negative underneath the bracket, and we can't screw it a negative. Okay, fg of 3, we know that's in that domain, so it should work. So fg of 3 means that wherever I've got an x, I replace it with a 3. So I get 3 minus 2, 4 minus 3, which we know is the square root of 1 times 1, which is the square root of 1, which is just 1. Okay, so the main thing to remember is if you've got two functions, you add them together or multiply them, their domain, where the two domains intersect, that will be the resultant domain of the function, the added function or the multiplied function. Okay, addition of ordinates. Now this is probably the most hated subject by most students who do methods. It's actually not that hard, but it's the concept that you've got to get used to. So when you add two functions together, basically all you've got to do is add each particular function's y value together. So if we have a look here, if I've got sketch the graph of f of x plus 1, we know that goes through 1, it has a gradient of 1, so it's going to be a straight line, something like that. So that's f of x. G of x, let's do that in green, it's 3 minus 2x, so it goes through 3, and it's got a gradient of negative 2, so I've got to move down 2 as I go across 1, down 2 as I go across 1, down 2 as I go across 1. So that graph is going to look something like that. Now, if we add the y values together, so let's have a look here. Firstly, I've got 1 and I've got 3. What's 1 plus 3? It's 4. Nextly here, I've got 1 and I've got 2. What's 1 plus 2? It's 3. Here I've got negative 1 and I've got plus 3. Negative 1 plus 3 is positive 2. And then if I do the same here, I've got 4 minus 3, which is 1. I've got 5 minus 5, which is 0. So this here, that is the graph of f plus g of x. Of course, this graph here is g of x. Okay, let's have a look at this blue graph and see if we can work out what the function is. It goes through 4, and it's got a gradient of -1. So I'm going to say f plus g of x is, goes through 4, so y-intercept of 4, and it's got a gradient of -1, so it's negative x plus 4. Okay, so that's our graph of the two functions added together. Let's do it using algebra. If I said to you f plus g of x, you would have x plus 1 plus 3 minus 2x. I've just added the two functions together. X minus 2x is minus x. 1 plus 3 is plus 4. And we got exactly the same function. The reason we use addition of ordinates, though, is because it's not always as easy as adding two linear functions together. Sometimes you'll have sin x, sometimes you have cos x, you might have e to the x, and when you want to add them together, all you have to do is get their two y values and add them together. Two y values, add them together, two y values, add them together. And once you add them, that'll give you your resultant addition function or subtraction function, depends on what it is. Okay, so this one here is a little bit harder. We have got the graph of y equals x squared, and it goes through 1, goes through 1, 1, it goes through 2, 4, so it looks like that. And it's going to go through -1, 1, -2, 4, so it's going to look like that. So that's f of x. Now, if you notice here, we're going to subtract. So what I do, to be smart, is instead of graphing root x, I graph negative g of x, which is negative root x. So I'm going to have, when I put 1 into that, and if I put a negative out the front, so negative root x. If I put 1 into that, I get negative root 1, which is -1. If I put 4 into that, I get negative root 4, which is -2. So that's going to look like this. Now, we know that if we add those two graphs together, or we subtract them in this case, f minus g of x, from what we learned at the start, I would have x squared minus root x, and our domain would have to be where the two domains intersect. Now we know x squared has a domain of all real numbers, and we know that root x has a domain of x is greater than or equal to 0. So where do those two things intersect? They intersect for greater than or equal to 0. So we can only add these two functions when x is greater than or equal to 0. And that makes sense, because here on this left hand side we've got that graph, but we can't add it to anything because it doesn't exist. And we couldn't put in values less than 0 into this function because we can't square it in negative. Okay, next off, I'm going to go with a black pen just to make it easier. We are adding 0 and 0. We get 0. Here, we're adding positive 1 and negative 1. They will cancel each other out. Here, we're adding 4 and maybe negative 1.2. So 4 take away 1.2 is going to put us about there. And as we go further to the right, the red graph is more powerful than the blue graph, so it's just going to continue to go up. Right, so it's just going to continue going up. Okay, in between -1 and 1, it's a bit tricky. We need to work out which graph is more powerful. So I'm going to say, let's find f of half. If I put a half into x squared, I get a half squared, which is a quarter. So when this thing is a half, that thing is going to equal, the red one's going to equal a quarter. If I say f of a half, g of a half, I'm going to get the square root of a half, which is 1 on root 2. So this is 1 divided by 4, and this is about 1 divided by 1.4. This number is going to be bigger than this number. So here, in between these, the blue is going to it's going to be more powerful than the red, so it's going to go through, it's going to go down. So it's going to drag it down and then back up. So that's our resultant graph. And we can have a look on our CAS to see whether we're correct. So let's delete what we've got in there. Let's sketch the graph of x squared and sketch the graph of negative root x will do. So root x, put my negative out the front, and then let's graph the graph of x squared minus root x. Okay, so there's a graph of x squared, there's a graph of negative root x, and there's the graph of the two added together. So you can see here it only did the right hand side because we can't use the left hand side, and it went down and back up through 1 and then continued up because this graph is going to climb quicker than this graph is going to go down.